So for this question, we are talking about permutations and combinations, and it's called problem type 1. So that's just kind of the introduction to this. And what this really is about is getting you to understand the difference between permutations and combinations. And the difference comes down to two things. First of all, permutations and combinations are both done without replacement. So if it's with replacement, then it's really simple, and that's a previous topic. But if it is without replacement, then you're either dealing with a permutation or a combination, and the difference comes down to whether or not the order matters. So if the order matters, in other words, the order of the choices is taken into consideration, so the order makes a difference, then you're dealing with a permutation. And if the order does not matter, then you're dealing with a combination. And so once you have that sorted out, these are really pretty simple. If you're dealing with we want to choose 6 objects without replacement from 13 distinct objects. So that is that NPR, where N is 13 and R is 6. And so that is 13 P6, written that notation. And what that means is 13 factorial over 13 minus 6 factorial. And you want to understand what this means so you can at least set it up by hand. But then we're going to use a calculator to actually do it. So, but nonetheless, so 13 factorial over 13 minus 6, that's 7 factorial. And then what that really means is if you think about that's 13 times 12 times 11 times 10, 9, 8, 7 factorial, I barely have room here, over 7 factorial. And that divides away. So all that you're left with is 13 times 12 times 11 times 10 times 9 times 8. Now, again, you can do that the manual way, or you can use a calculator, and we're going to show you how to do that. So if we just do, let's see, find the math button, there it is, over to probability, one more over to probability, and I want to use the permutation thing, the NPR, so I'm going to press enter. I'm going to put a little 13 right there, and I'm going to put a little 6 right there, and I'm going to scoot over, and then I'm just going to say enter, calculate. Now, just so I show you, if you remember what we said that was 13 times 12 times 11 times 10 times 9 times 8 times, oops, the 7 factorial, so I already don't need that. I'm going to delete the 8. There we go. 7 factorials divide away, and notice that's that same value. So using the 13p6 or just the NPR permutation calculation feature within your calculator is perfectly fine. So that first one, how many ways can this be done? The answer is 1, 2, 3, 5, 5, 2, 0. So I'm going to write that down here. 1, 2, 3, 5, 5, 2, 0. Back up, put a comma, put a comma. So 1.2 million different permutations. That's how many different ways you could select 6 objects from 13 distinct objects. So the other one, NCR, so that's combinations. So we're going to use the NCR, and that is, again, N equals 13 and R equals 6. And so what does that mean? That means 13C6. And using the combination formula, that means 13 factorial over still the same 13 minus 6 factorial, but it also has a 6 factorial. So in general, when you're talking about the difference between permutations and combinations, combinations are going to be much fewer in the same scenario because you're dividing by an additional 6 factorial in the denominator. So I'm not going to write all that out. We're just going to use that on our calculator. And we're going to say math over to probability down to option 3. And that's again a 13 there and a 6 there. And that's 1,716. So there are 1,716 different combinations. That's how many ways that can be done if the order is not taken into consideration. And I'm just going to scroll down just a little bit and say something about the ALEKS explanation. If you look at it, here's some background. That's just explaining permutations. That's the permutation formula. There's the combination formula. And there you see how they calculated the permutations for part A and the combinations for part B. As you do this question in ALEKS, they're going to mix it up. Sometimes you might have 2 permutations. Sometimes you might have 2 combinations. Sometimes you have 1 of each. So just read it carefully and just understand that if order matters, so if the order is taken into consideration, then it's a permutation. If the order doesn't matter, then it's a combination. That's the key.